So we previously have been talking about finding the area between a curve, a function, and the x-axis. We do that by finding the integral. Now we're going to extend that application a little bit and talk about finding the area bounded by two curves. So here's the definition, and there's a little picture to show you what we're talking about. So if we have two graphs, I'm going to call them f of x and g of x. To find the area bounded by those two graphs between two x values, you are going to do the upper function, and by upper I mean higher up, minus the lower function. So just make sure that you do those in order. Same thing as you had before when you were doing the area. The thing on the bottom of the integral is the lower x value. So A is the lower one, B is the upper one. Make sure if you're finding the area that you do that. So what this is going to give you, I'll show you the shaded area that we get. So you can think of it as like this is a dotted line. This is x equals A. This is x equals B. So this is going to give us the area between these two curves. You'll notice that it's going to have stuff both above and below the x-axis. We are not going to say that the stuff below is negative. It's all going to be positive. So when we do the area between two curves, we're going to always get a positive value. Actually, if you don't get a positive value, that usually means that you put something out of order. You either did the limits of integration, the a and the b, out of order, or you did the two functions, the upper and the lower, out of order. So just note that. So my first example, we are going to find the area of the region bounded by y equals x squared plus 2, y equals negative x equals 0, and x equals 1. I highly recommend for all of these problems that you draw a graph. Drawing a picture will help you immensely, and it will prevent you from making major mistakes. So please draw a graph. Actually, go ahead, pause the video, and I want you to draw a graph of these four things. So you might have noticed that I drew dotted lines for the x equals 1, x equals 0. It actually doesn't matter. You don't need to do that. You technically can get by without even drawing those two things as long as you realize that your cutoff points are at 0 and 1. So the area that we're going to be looking for is going to be this right here. So we're going to be looking for this shaded area there. So I think it's always a good idea to draw your shaded area first and then write your equation. It's really hard to do it without drawing a picture first. Okay, so like I said before, do not concern yourself with the stuff below the x-axis being negative. You're going to find that will be taken into account when you do this integral. Some of the questions that you get for this, you're just going to have to set up the integral. Other questions, you're actually going to have to find the area. For all of these that we're going to do today, we're going to find the area. So let's go ahead and we're going to first set it up. So our x values are going to go from 0 to 1. Now we're going to have our top equation, x squared plus 2, minus our bottom equation, negative x. And we're going to take the integral of that. I would like you guys to pause and do that on your own. Okay, so when we work that out, hopefully we end up getting the right answer. We end up getting x cubed over 3 plus 2x plus x squared over 2 evaluated between 0 and 1. You're lucky I gave you some nice numbers here. I get 1/3 plus 2 plus 1/2 minus, all of these are going to be 0. So it's not too bad. Sometimes you're going to get things that are a lot worse. If you combine everything together, you end up getting 17 over 6. And you're welcome to write 17 over 6 units if you get a question where you're looking for units, but 17 over 6 is perfectly acceptable. Like I said before, you do not need to do anything about the stuff below the x-axis. That is already accounted for in your integral. So for my second problem, you'll notice I didn't actually give you any x values, which means that you're going to have to find the intersection points on your own. So please pause the video and graph. So your graph hopefully looks something like this. You can most likely see that the top equation is y equals 2 minus x squared, and the bottom equation is y equals x. So I'm gonna start writing the integral. So we get 2 minus x squared minus x. Notice that I call these f of x and g of x. Even if the first one had been called g of x and the second one had been called f of x, we would still do it in this order. Once again, make sure that you keep whatever equation is on the top, whatever function is on the top first, and whatever one's on the bottom second. So you're doing the upper minus the lower. Now we need to figure out our limits of integration. You might be able to guess what they are based on what these points are. If you know what the points are, that's great. But I think it's safer to make sure that you can find those points. So what I'm gonna do is I find the points by setting f equal to g. And we're gonna do this to find our limits of integration. And we are going to be looking for the x values. We know that we're looking for the x values because we have a dx here. There are going to be occasions where we're looking for the y values. I'll talk about that later. So we're going to set these two equations equal to each other. I get 2 minus x squared equals x. And this one is a nice factoring one. I end up getting x squared plus x minus 2. That factors to x plus 2 times x minus 1. That gives me x equals 1 and x equals negative 2. And you can look at this and you can see that, that this is at negative 2, this is at 1. You're welcome to go back and find the y values also, but we're actually only concerned about the x values because we have dx. So my lower x value, my leftmost x value is here at negative 2. My rightmost x value is here at 1. And again, I have that same, I have the two things in the integral subtracted from each other. Go ahead and I want you guys to just take a minute to find this one. Unfortunately, this does have a lot of fractions. For now, you're welcome to use your calculator. I will tell you that this on the AP exam would be a non-calculator question, however. So hopefully when you took the integral, you got 2x minus x cubed over 3 minus x squared over 2. If you combine everything, I'm not going to show all the steps, but I'll show you some of them. You end up getting this right here. End up getting negative 4. I get minus negative 8 over 3, and I get minus 4 over 2 here. So if you combine everything together here, you should hopefully get 9 over 2 or 4.5. So for this next example, this is going to get a little bit harder, and it's not just because there's a sine and cosine, although that certainly does make the problem a little bit more challenging, but it's also a little more challenging because there's going to be an extra step. So I would like you to, on your own, pause the video and try to graph y equals sine x and y equals cosine x on the same axis. So here's the graph of this. You'll notice I didn't graph, I only graphed one period of it. By the way, the period of sine and cosine is 2 pi. This value right here is pi. So you need to figure out where is my shaded area going to be. The other thing you're going to have to figure out is where do sine and cosine intersect. Now, I'm hoping you remember a few things about the way these graphs look. This is pi over 2 right here. So there's something that's a little bit helpful. So we know that sine hits its maximum point at pi over 2. Cosine has an intercept at pi over 2. If you're like really stuck on these, you can always make an XY table. You will need to know some basic things. You can either draw a unit circle or just evaluate them any way that you know how. By the way, not a calculator. This is a non-calculator problem, believe it or not. You do need to know a few important things from the unit circle. So for this problem, we are actually finding this shaded area starting at 0, which is here, all the way to pi over 2. And the thing about this problem that makes it different from the previous ones, other than the trig part of it, is that you have sine on the top for half of it, but you have cosine on the top for the other half of it. So what you need to do because of this point is you need to split this into two integrals. And actually, you also need to figure out what is that value there. And you can find that, there's a few ways to find it. I usually just think about like setting the two things equal to each other to find that intersection point, same thing we did previously. The value that cosine and sine are going to be equal is actually going to be at pi over 4. So if you don't remember, I'll draw like a mini portion of a unit circle here. So unit circle at pi over 4, that's the point radical 2 over 2, radical 2 over 2. So sine and cosine, sine is the x, cosine is the y. Sine and cosine are equal there. So that's a helpful thing to know. So we know this point is pi over 4, so that's a good start. Now we need to split this up depending on what's on the top. So I'll actually write out what we're going to do. So here I wrote it out in words just so you could see what's happening. So from 0 to pi over 4, the cosine x is the upper function. From pi over 4 to pi over 2, the sine of x is the upper function. You're welcome to actually, I would like you to try to see if you can write the two integrals on your own, and then we'll do them together. So pause it and try it out. All right, so the first half of my integral, or the first half of my area, I'm going to write a equals actually, is going to be from 0 to pi over 4. At that point, cosine is on top and sine is on the bottom. So I'm going to write it as cosine minus sine. The second portion is going to be from pi over 4 to pi over 2. For that part, the sine is on the top and the cosine is on the bottom. So this is kind of a long process. It is a pretty long integral. There's a very good chance that if you had something that was this complicated on the AP exam, you would actually just be required to set it up. You wouldn't necessarily have to evaluate it. Now we are going to evaluate it. I'd like you to see if you can evaluate this on your own. So please pause. Okay, so for my first integral, the antiderivative of cosine is sine of x. The antiderivative of sine is negative cosine, so actually we're going to get plus. It's going to be minus cosine, so we get plus cosine. That's from 0 to pi over 4. The next portion of this is almost the same exact thing, except things are just going to be switched around a little bit and they're going to have different signs. So the antiderivative of sine is negative cosine. The antiderivative of negative cosine is just going to be minus sine. It's going to look like this. And then we're going to have to evaluate these. This is where it's really useful if you remember some pieces of the unit circle. If you do not remember pieces of the unit circle, I do recommend that you at least know what the first quadrant looks like. So we have a point at we have a point at 1, 0. That's when it's 0 radians or 0 degrees. We have a point at 0, 1. That's pi over 2. The other point that we're going to need here, you'll notice I'm only filling in the ones that apply to this particular problem. The other one is that we have radical 2 over 2 and radical 2 over 2. I actually mentioned that one earlier. That's going to occur at pi over 4. So hopefully you at least know those 3 points. They will definitely come in handy. All right, so we're gonna get something kind of long. There's a lot going on here, but luckily many things are equal to 1 or 0, and then other things are going to cancel out. So it's not going to be actually too bad. Okay, this part in pink is the first integral right here. The second integral I'm just going to do in this dark purple. I am going to run out of room here. Like I said, this is pretty long. So then the second part, I have negative cosine of pi over 2 minus sine of pi over 2. That's going to be minus negative cosine of pi over 4 minus sine of pi over 4. All right, let's see what we get now. So sine of pi over 4 is radical 2 over 2. cosine of pi over 4 is radical 2 over 2. That's my first parenthesis. Second parenthesis, sine of 0 is 0. Cosine of 0 is 1. My third parenthesis, I have negative cosine of pi over 2. That's actually going to be 0. You don't have to write negative 0, but it is 0. Then I get minus sine of pi over 2 is 1. And then my last parenthesis, I have negative radical 2 over 2 minus radical 2 over 2. So let's see what we get now. So right here, radical 2 over 2 plus radical 2 over 2 is going to be 2 radical 2 over 2, which is equal to radical 2. 1 plus 0, we know what that is. And same thing here, we get negative 1. And then this last thing in parentheses, remember negative radical 2 over 2 minus another radical 2 over 2 is 2 radical 2 over 2, which just ends up being negative radical 2. So let's go ahead and finish this up. I'm actually going to just write it out so that it's a little bit friendlier looking. So I end up getting 2 radical 2 minus 2. So this is a longer than average problem. I figured, though, it would be good to give you one that has a little bit of review of trig because it is going to come up quite often. So it's good to have that built into this. All right, we have one more problem. And this one is a little bit weird. You'll notice I have things written in terms of x, not in terms of y. And in fact, if you want to solve for y, you can, but it gets really, really complicated. You're welcome to try that on your own. If you do it, you're going to actually have to do multiple integrals, and they're not going to be easy. So I actually do not recommend that you try to solve for a y equals, because this first one is not actually a function. So I'll show you the way that we can do it. If you remember how to graph these things, that you probably did it when you did conic sections, go ahead and try. My hint, though, is honestly, for the first one, I think the easiest way to do it is to do an XY table. But when you do the XY table, choose some values for Y, and then find X from there. That's my recommendation. So go ahead, pause, and try that. Okay, so graphing this thing is, it's a little challenging. So let's say I have y equals negative 2. When I do that, I get x equals negative 2 squared minus 2. That gives me 2. If I do the same thing for y equals negative 1, I end up getting x equals 1. If I do that for 0, I get x equals negative 2. When y equals 1, I get x equals negative 1. When y equals 2, I get x equals 2 again. So let's first of all, let's draw that graph and see what we get so far. I do want you to recall that if you have an x equals y squared and the x is not squared, that is a sideways parabola. So I'm hoping that you have seen that in the past. If you did conic sections and you remember that, that would have been when you hopefully were able. And actually, I just noticed a little mistake. It should be negative 1, negative 1. So let's go ahead. We can plot our points. So if I plot them, I get this. This is looking pretty good. You will notice that it does end up giving us a sideways parabola. Not exactly the perfect graph, but hopefully you get the idea. So this is the graph of x equals y squared minus 2. Actually, I kind of know what this looks like just based on the equation. I know that x equals y squared is a parabola that opens to the right and has a vertex at 0, 0. If I have minus 2, then it's just going to be shifted over to the left. It's the same idea as if you had y equals x squared minus 2. It's just that it gets flipped around. Okay, so now we have that. Let's go ahead and draw the graph of x equals y. And this is actually the same as y equals x. So at least thankfully that one's a little bit easier than some of the other ones. And my graph is definitely far from perfect, but Hopefully yours is a little bit better. If you have graph paper, you definitely will be able to find a nicer graph, have a nicer graph. So here's what we're gonna be doing now. We need to write a integral, but rather than integrating from using our x values, we are going to integrate in terms of y. I'll write out the formula for you. So previously we had like an x value as our bottom limit of integration and a y value as our top. Now what we're going to actually do is we're going to shift everything around. So we're going to think about our bottom y value, which is going to be whatever goes through here. This is y equals our bottom value, up to our upper y value. I'm going to call that y equals a and y equals b. So y equals a, that's going to be my lower value. My lower y value, and y equals a is my upper y value. The other thing that we need to remember is that we're now working kind of backwards or sideways. So our upper value that we're going to be integrating is going to be I'm going to call it f of y, but actually I think it's better if you, rather than remembering it that way, if you remember that it's our right side one minus our left side one. So I'm going to say f of y minus g of y, so it's going to be right minus left. This time we're going to be integrating with respect to y, so you're going to have a dy. We'll do some more practice with this, but keep in mind that when we're doing things with respect to y, the upper value is going to be the rightmost, the lower value is going to be the leftmost. And if you have a dy here, make sure that these values are also y's. That's really, really important. So think about when we're doing dx, you go from like lower to upper. When we're doing dy, you go from left to right. So I'd like you to try, even if you think you're going to be super wrong, pause the video. I want you to see if you can try to set up the integral. You don't even need to do the limits of integration. See if you can just set it up. Okay, so our setup from this, our rightmost thing is going to be this x equals y. Remember, we're doing it with respect to y, so that's going to be just y. Our leftmost thing is going to be this thing right here. It's going to be y squared minus 2. Remember, this is a dy. Here's the next thing. We need a y equals and a y equals here for our limits of integration. We can find those the same way that we found them in the previous example, which was by setting the equations equal to each other. So I am going to set y squared minus 2 equal to just y. So those are my two equations. Sorry, I ended up in highlighter mode. And if you solve those out, I get y squared minus y minus 2 equals 0. If I factor that out, I get y minus 2 times y plus 1 equals 0. So I have values at y equals -1 and y equals +2. And you can kind of see that this value right here is going to be at -1. This value up here is at +2, which is good because we want that to happen. Okay, so now that I have that, I can actually find the integral of this the same way that I would find any integral. Go ahead and pause the video and try that. So hopefully when you did that, you ended up getting this integral right here. You might realize that this is actually, I think it's almost the same exact problem that we did just a few minutes ago with, except that we had like x squared and x instead, but it was almost the same thing, just kind of shifted around and flipped around. I'm not going to show you how to evaluate this. I'm hoping you can try that on your own, but you should end up getting an answer of 9/2.